Okay, so this is lecture 30, in which we continue discussing section 5.2. We introduced expectation of a continuous random variable, and we developed a proposition, which I'll review, and today we're going to talk a bit about variance as well. Okay, so let's get started. So I'd like to remind you all of the setup. So we have a continuous random variable, x, and we have associated to the probability density function, f of x. Okay, and then let's g of x be any function on the real line. And then we saw that in proposition 2.1 that the expected value of the random variable g of x, so g of x here is g of capital X, this is a new random variable. The expected value of this new random variable is the integral from minus infinity to infinity of the product of g of x with f of x dx. Okay. So I want to do an example of a computation with this. And the example is example 2C in the text. And it goes like this. You have a stick. So let me draw a picture of a stick. Here's a stick. And it has unit length. We might as well put the stick at the origin. And then you have a point on the stick, some randomly chosen point. We can call that point P. And the stick is cut or split at a point U. Okay, so we cut the stick at a point U. Maybe it's here. That's U. And the question is, and the density, we'll assume the probability density of how it's cut, the point U, which is a random variable, has a density function f of u equals 1, where u is a number between 0 and 1. Okay, so the random variable here is the point between 0 and 1 that's chosen. And then the question is the expected value, what is the expected value of the length of the piece of stick which contains the point P that you started with. Okay, now there are two possibilities. The point P that you chose, you put here, it either, so the length of the piece in this case would be the length of this piece here. But it could be that there's another possibility, which I'll draw on top. The other possibility is that maybe P was over here and U was here, in which case, because the stick has unit length, the length of the piece of stick which contains P is not U, it's 1 minus U, right? So because the distance from 0 to U is U. Okay, so let me formulate that on my next slide because I need some room. So here's the formulation. So let L sub P of U, This is a fancy notation for a function. It's the length of the piece that contains the point P. And we just saw that L sub P of U is given by the following. If U is less than or equal to P, then it's 1 minus U. And if U is greater than P, it's U itself, if you go to the previous slide. So we can now compute the expected value of this function using proposition 2.1. It's the integral. Now we're integrating from 0 to 1. We take the function, and then we have to multiply it by the probability density. But the probability density here was given by, recall, f of x equals 1, or f of u equals 1, I should say. So we have to multiply it by 1 and integrate over u. So what do you get? Well, the function is given in two branches. Between 0 and p, the function is given by 1 minus u du, and then from p to 1, so u is between p and 1 in the second case, and u is between 0 and p in the first case. So we're integrating from p to 1, u du. So what do we get? Well, the integral of 1 minus u du is u minus u squared over 2, evaluated from 0 to p. And then the other integral is u squared over 2, evaluated from p to 1. So what do you get? So if you evaluate it at p, you get p minus p squared over 2. And then evaluating at 0 does nothing in the first case. Now, then we go to the second expression, u squared over 2. We're going to get 1/2 minus p squared over 2. So what are you going to get? You're going to get 1/2, if we simplify, plus p minus p squared. And that's the answer, but the book likes to write it as 1/2 plus p times 1 minus p. So that is the answer to the expected value of the length of stick that contains the point P. Okay. So, so that's an example. Now we do have a corollary to the proposition 2.1, and it goes like this. So let x be a continuous random variable, and then the expected value, and let a and b be any constants. So then the expected value of the new random variable given by ax plus b is given by a times the expected value of x plus b. So since the proof of this is pretty easy, I'm going to give it to you. So the proof goes like this. What is the expected value of ax plus b? Well, by proposition 2.1, which we proved, it's the integral from minus infinity to infinity of a x plus b times f of x dx, where f of x is the PDF. So with PDF, f of x. Okay, so then what is this? This breaks up this integral. It's a times, you can just break up the integral in the usual way, a times x times f of x dx plus b times the integral from minus infinity to infinity f of x dx. But the first term is a times the expected value of x, and the second term is b times the integral, the area under the PDF, which is 1. So that does it. That shows you why this is true. That's the proof. Okay. So we can now turn to the last part of the section of 5.2, which concerns the variance. Okay, so what is the setup for that? It's the same as before. You have x is a continuous random variable, but now we're going to set mu equal to the expected value of x in what follows. And then the variance, and I'm not going to prove this, it's easy to establish. Or you can even define it this way if you want. You take x minus mu, you square it, and take the expected value of that, and that turns out to be the same thing as in the discrete case, the expected value of x squared minus the expected value of x quantity squared. So here is, I'm going to give you an example in a moment. In fact, I'll give you an example now. So let's find the variance in the example that I gave before. Example 2C in the book. Okay, so how does that work? Let's see. So remember, let's set y equal to that function L sub p. This is the stick problem. Okay, so recall that we showed that the expected value of y is equal to 1/2 plus p times 1 minus p. So now what is y squared? Well, remember we calculated a formula for, let me do it up on the top here, for what L sub p of u actually is. It's given by, what did I get? I got 1 minus u for u less than or equal to p. And then u for u bigger than p. And here u is between 0 and 1. That's by assumption. Okay. So if we square this, we're going to get the function 1 minus u quantity squared if u is less than or equal to p, and y squared of u. It's a function of u. And then it's going to be u squared if u is bigger than p. And again, the assumption is u is between 0 and 1. Okay, I'm going to need more room here, but I'm going to use the fact that I'm going to be using this formula here, the one on the right, for the variance. So I have to calculate the expected value of y squared and subtract off the square of the expected value of y to get the answer. That's what I'm going to do on the next slide. Okay, so how does that go? Well, the variance, so first of all, let's compute the expected value of y squared. Well, if you go back to the formula that I just calculated for y squared, you're going to get the integral from 0 to p of 1 minus u squared du, because we're using the PDF f of u equals 1, remember. That was the PDF for the problem. And then we're going to integrate from p to 1 u squared du. So this is the second moment, if you like. And what do you get? Well, when you integrate 1 minus u squared, you get minus 1 minus u cubed over 3 from 0 to p, and then you're going to get u cubed over 3 from p to 1 evaluated. And if you figure out what this is, what do you get? Well, when you stick in p, u equals p, you're going to get minus 1 minus the quantity p, 1 minus p cubed over 3 minus the negative of 1/3, it looks like to me. And then the other term is going to be 1/3 minus p cubed over 3. Okay, and now we know what the expected value of y was. I had that on there. So if you sort of calculate the variance here of this y, you're going to get, so the negative 1/3 isn't a positive 1/3. So you're going to get 2/3, and then you're going to get you can combine the p cubed over 3 with the 1 minus p cubed over 3 to get p cubed plus 1 minus p quantity cubed over 3. I'm going to leave it like that. And then we have to subtract off the expected value of y. What was the expected, and squaring it. So that's 1/2 plus p times 1 minus b. And we have to square that. And so that is the answer to the variance of the stick problem, which was not given in the book, by the way, as far as I know. Okay. So let me end this lecture with the following fact, which is the same as in the discrete case. So if x is a continuous random variable, the variance of ax plus b, where a and b are constants, is given by a squared times the variance of x. So you lose the b, and the a gets pulled out as an a squared. So that's the end of this section 5.2. We're done with 5.2.